Hi everyone, and welcome to Mike Likes Robots. Today we're going to be looking at how to take ROS2 logs and forward them into CloudWatch to aggregate them and make them searchable. And because the modification to the code isn't that complex, I'll guide you through the coding so that we can see how to extend the AWS sample IoT node. Here we are in the AWS console looking at the CloudWatch service page. CloudWatch is all about different functionality to watch what's going on with your cloud resources. There's a few different categories that you could be using here. For example, in metrics, you could post metrics for different robots or for other services. This is what you would use for your EC2 instance if you wanted to monitor what kind of CPU usage it had or what kind of RAM usage. You could set alarms, which would say, if the CPU is more than this used for this long, then I need to know about it, alert me. But what we're most interested in is this logs. CloudWatch gives you the ability to post logs into log groups so that you can organize them. Each log has a number of streams. We'll see more about logs, log groups, and log streams later on when we start posting messages from our IoT node. Our starting point for the code will be the same code that we used in the How to Send ROS2 Data to AWS IoT Core video that I'll link at the top and in the description. The first step will be to listen to messages from ROS out, which are the log messages. The next step will be to publish them to IoT Core. Then we'll add an IoT rule to forward them into CloudWatch, and then we'll see the messages appearing in CloudWatch and figure out how to filter them. So let's get started. So here we are in VS Code, and all we've got at the moment is the same sample code that we used before to send messages into AWS IoT Core. What we're going to be doing is adding a new subscription that listens for log messages from ROS. Then we'll be publishing them to IoT Core and making sure they come through. Then we'll be adding a rule that creates CloudWatch logs from our IoT Core messages. Then we'll check CloudWatch to make sure those messages are coming through correctly. So the very first step is to make sure our workspace is built and our environment is set up. To do that, we can execute colcon build, and we'll add the symlink install argument. What this does is says to symlink to the Python files instead of copying them to a new location. By doing that, any edits that we make to the Python will be used immediately instead of having to rebuild the workspace again before they take effect. Our build has finished, so we can make sure to source our install setup.bash. Now we can test that this is working correctly by running the two nodes. On the right, we'll run our mock telemetry node. And on the left, we'll run our MQTT node. Now we'll check the AWS console to make sure the data is coming through correctly. And we can see here that our messages are coming through on the mock telemetry topic, exactly the same as in the previous video. Now we can start to make our changes. Let's kill this node and open up the source code. In this code, we have the constructor. We have some functions to allow connecting to MQTT. And we have our subscription initialization and callbacks. So we're going to copy the code that's already here to add a new subscription. This time, the topic we're listening to is ROS out, and we can find this by doing, while the mock telemetry node is running, we can do ROS2 topic list, which shows us these topics running. Now, if we do ROS2 topic info on ROS out, we can see that it takes a log message and it has two nodes publishing to it. So we can edit this to be ROS out. This argument will leave the same. It's not a string message, it's a log message, so we need to change that. And because it doesn't know what a log is, we need to import that. So back at the top of the file, we know it's RCL interfaces message. So we can do from RCL interfaces.message import log. We want to handle it differently from our other code because we want to publish it on a different topic and because it's a different message type. So let's create a new callback function. we'll call it log callback. And to help us out here, we'll use Python type hints. So I can put :log, which tells me that the incoming message is expected to be a log message. Now, to keep things simple, instead of publishing, I'm just going to print what I would have published. We don't know what topic is yet, so let's figure that out. Our topic can simply be log. But to help us out in the future, we're going to change this a bit. We're going to add a new argument, which is the thing name that we're using for connection. Now this field isn't saved, so we're just going to go to the initializer node, and we can see that the cert data is loaded here. So we can add self.client ID equals cert data client ID. We can see later in the file that the client ID is used, so we have the spelling correct. So now we've saved it as part of the class, we should be able to access it inside the log callback. Now our message JSON isn't message.data anymore. Now we have file, function, we have a few different arguments that come from the log class. So if we click on log and press F12, we can see what's available inside it. We can see the level, we can see the name, we can see the message, and so on. So what we'll do is construct a new JSON message. And we also want to know the name. So we'll use, again, this self.client ID. Now this line has a danger of introducing recursion, because every time we get a log message, we call this function, and this function produces another log message. So it will continually call itself and nest the message deeper and deeper and deeper. So we can take this out and just use prints while we're testing. So this looks good to me. Our mock node is still running. We don't need to rebuild because of the symlink install. So let's run the node now. And we can see that it's published to topic test ROS2 thing log, and the message is, and it has a number of fields. So now that we're confident that we're receiving log messages and we're able to print them out, let's start posting them to IoT Core. We have our topic already defined. We have our message JSON already defined, and we have our quality of service already defined. So now let's run this node. And it seems like it's receiving messages. So let's check in our test client. Now we can see live messages coming in, but we're not seeing anything appearing. We should see test ROS2 thing log here, but we don't, even though we're subscribed to all topics. So what's going on? Is it a permission error because we're not allowed to publish to that topic? Well, there's a couple of ways that we could test that theory. The easiest way to test that is to add a policy to our certificate that allows all operations. Now, only do this if you know nothing else is using it, because it could lead to a security vulnerability, and be sure to undo it afterwards. But in this case, I can check the certificate for the thing, open it up, and attach a new policy. I already have IoT full access defined, so I'm going to tick that and attach it. That will give me permission to publish on all topics, and it will be effective immediately. But our message still isn't coming through. So what could be going wrong here? The problem in this case is that we're passing an argument into the publish function that's not allowed. This message JSON can't be a dictionary, it has to be a string. What we haven't done is encode it. This is one of the dangers of using Python, is that it will let you do things like this. And because the error happens in a callback function, and we don't print anything in case of an error, we never see it happen. So it's just silently failing. Now we've made that change. Let's rerun the node. And in our console, we're now seeing this ROS2 thing log topic appearing with our log messages in. So great, we're getting those messages, but that's through adding IoT full access policy to our certificate, which we don't want. So now let's detach that policy and edit our robot IoT policy to allow for that topic. We can do that by edit active version, go into the JSON, and we're going to change this field. Instead of being a singular field, we'll make it an array. And we can copy this line and allow our certificate to publish on any topic that starts with test ROS2 thing. We could make it specific to log, but I think it's fine to allow our particular thing to publish on any topic as long as it starts with test ROS2 thing. We don't need to subscribe to this topic, and we don't need to add a connection. So now we'll tick set the edited version as the active version and save as new policy. Now that again will take effect immediately, and we can see that our messages are still arriving on this topic. So our permissions are all set up correctly, and we're now receiving messages into IoT Core. The next step is to add an IoT rule that forwards the messages into CloudWatch. And we're going to scroll down and look at message routing rules. IoT rules are the same mechanism that we used in the Sitewise video that I'll link at the top and in the description to ingest data from our IoT Core messages, from our MQTT messages into Sitewise. That's why this rule is already existing. But we're going to add a new one and create it by hand. So our new rule name will be ROS2 log rule. Here we need to add our SQL statement. So we're going to select all fields from our message. It will be from any topic that ends in /log, and we don't need a where clause. Now, the from field here is expected to be a string, so make sure you add those quotation marks. Next, we need to choose what happens with the data that comes in on log topics. And we can choose an action and send the message to CloudWatch Logs. Choose a CloudWatch log group. We don't have one yet, so we'll click this button. And we'll enter a log group name of ROS2 logs. Everything else is fine, the defaults, so we click create. And now we can refresh this list and choose ROS2 logs. We're going to do a similar thing here for IAM role. We'll create new role, and we'll add ROS2 log role. And that's automatically inserted. Now we could use batch mode. We could save costs of inserting data into CloudWatch by collecting together a bunch of log messages and sending them in one batch. But just to keep it simple, I'm going to put them in one at a time. So that's our rule completely set up. We'll click next and review, and that all looks good. So we'll click create. Now our messages are still coming in on this log topic. Everything else has been done in the cloud. So now we can go straight to CloudWatch and see if those messages are coming in. One way to do this is with the live tail mechanism under logs. And we can select the ROS2 logs group and apply filters. And we're seeing the events coming in now. They seem to be coming in 2 or 3 at a time, but we're seeing the battery measurement and the velocity measurement coming in. So now that we've generated some data, let's kill that node running and take a look at what messages are in the log root. So we can click on log root and we can click on ROS2 logs. Now it's separated into log streams and it seems to have one log stream per message, which is automatically done by the log rule. So we can click on a log rule and see what message has been inserted. It has a timestamp of when the message was ingested and a message which is JSON formatted that CloudWatch understands. Now, if we don't want to look at messages one at a time, an easier way is to search all log streams, and we can see all the messages that came in. But more than that, we can start to apply our filtering rules. We can select a time range that we want to search across. We can also start to enter filter patterns. For a more comprehensive guide on filter patterns, click this button or I'll link it in the description, but it shows you how to use regular expressions to search across all your logs. Now for this, our level is 20, which isn't that useful for us to search across. So we're going to add another modification to the code to map that to a real level. In this case, we'll enter the log file, and I know that there is a message at the top that was generated from a particular file, and that's what defines our log level numbers. So if we open this log message up, it tells us that debug is 10, info is 20, warn is 30, and so on. So we're going to add this to our code by adding a map that we use to decode the log level integer into a string. So here we can add a map of log level from integer to the string that we want as a human readable format. So we can add log level map is equal to 10 is our debug message, and we can proceed to add 10 and add the log level. There are all the log levels. Now in our message, when we format it, we need to look up the log level. So here we can do log level map get message.level, but just in case the level doesn't exist in that dictionary, we can add or unknown, meaning it wasn't found. This will only happen if get doesn't have an entry for what it's passed. So if we pass in 15, that doesn't exist in the dictionary, the get function will return none, and then the or unknown will overwrite the none with an unknown string. So we'll always have something there. Now, if we run that code again, we can start to insert messages with human readable log levels that we can search for. Now, by default, our messages are appearing oldest first, which is why we're still getting some 20s in. But if we scroll down, we can see that the info messages are appearing. Now, if we want to filter by log level across our whole fleet, we can do $.level equals info. And if we search this filter, it will show us all info level messages. That's because it understands the JSON field is level and has to match info. It also understands regular expressions. So we can do *I* to mean match anything containing the capital letter I. And that shows us the same thing, the info messages received. We could alternatively search for all log messages with our robot name. Now this will load all events with test ROS2 thing as a name. This is really helpful if we want to be able to search across an entire fleet for a particular severity of message, a particular robot name, for a particular field within our error message. And it allows us to start building up a better picture of what's going on across our entire fleet. In addition to the console, we can also run the same search using the command line interface. We can do this with AWS logs, filter log events. And we'll run the help command here. And then if we scroll down, we can see that we need to pass either a log group name or a log group identifier. And we can optionally pass a filter pattern. So that means that we can run the same command as we did in the console. For instance, if we had a fleet of delivery robots and we wanted to identify all the error events that had happened, we could use the CLI to generate a report. We can pass those logs and decide to do something with that information, all automated. Let's run an example command. log group name is ROS2 Logs. And our filter pattern, this is a JSON encoded string. We need to give it the same format but escape quotation marks. So this command, when we execute it, will give us all CloudWatch logs that have the name of test ROS2 thing. So we can see it's returned a JSON blob with events as a field that contains an array of all our log events. Now, I didn't specify a time period on this, so it's just given back all the messages that I've produced today. But we can see we can scroll down and start to look at all the results from CloudWatch. So there we've seen how to filter using the console and using the command line interface. You can start to see how we can aggregate logs across a robot fleet and start to do powerful searches with regular expressions, or searching by name or log level, or any other field that you choose to put inside your node. So there we have it. We've seen how to extend the AWS sample code for sending ROS2 messages to IoT Core. We've also seen how to route messages from IoT Core into CloudWatch, allowing us to aggregate messages across our entire fleet and allow for powerful log searching capabilities. If you're interested, try checking out the repository for yourself and see if you can make the same changes that I did without looking at the video. Thank you for watching. Let me know if this was useful, and I'll see you in the next one.